Start number one. Baseball is hit nearly straight up into the air with a speed of 37 meters per second. How high does it go? How long is it in the air? So, first thought that should hopefully come into your head is, what about this object that's in free fall? What is going? Not going to be traveling at 9.8 meters per second. Accelerate. So, probably the first thing I would put in my y is that it is in free fall. So, acceleration is 9.80 meters per second squared down. Is that only when it's traveling down? Is it accelerating differently on the way up? What do you think? Is this acceleration only when it's traveling down, or is it, and it has a different acceleration on the way up, or is this for the whole trip? This is for the whole trip. Right. Anytime anything is in free fall, it always has this acceleration. So other things to keep in mind when you're looking at these, like this one, we draw a little picture. Starts here, goes up, comes back down. Now, they don't tell us, but we need to assume in this one that it lands at the same height that it started at. All right? Because, well, if we don't, it's unable to be done. So I'm just going to put that in. Lands at the same place, let's say, as started. So it started, at shoulder high, and it comes back down to that same height. There's some little things to realize. Let's see, we'd have an acceleration down. What's it doing on the way up? Is it speeding up, staying at a constant speed, or slowing down? Slowing down. What's it doing on the way down? Speeding up. So what does it have to do right here at the top to be able to change direction? It has to stop. So its speed has to be 0 right at the top. Let's see, and we said it was going up here right at 37 meters per second. And its acceleration, we said, is about 9.80 meters per second squared. All right, so this is, let's see, let's just double check what they ask us about. How long is it in the air? Talk to your table group for a second, but if it's accelerating this way the whole time, and it lands at the same place as it started, think about how long does it take to go up compared to the time it would take to come down. So it starts at this high speed, goes to 0, and then comes back down. The whole time its speed is changing at the same rate, at 9.80 meters per second squared. Do you think it's going to take longer to go up than to come down? The same time to go up or come down? Or less time to go up than to come down? Talk to your table real quick, see what you come up with for an idea on that. Exactly the same time. And one way I think about it is, if I just kind of estimate the time in my head, this is about 10, right? And that's about 40. Pretty close. So, if I think about every second on the way up, that velocity is going down by 10. So it starts at 40. After a second, it's 30. After another second, it's 20. After another, it's 10. And after 4 seconds, it's 0. And then on the way down, it's after the first second, it's going to be back to 10, but negative. and then negative 20, and then negative 30, and then negative 40. So by the time it gets here, not only is it going to take the same amount of time to go up as it does to come down, I also know that right here at the bottom, it's going to be moving at 37 meters per second downwards. So that's not something I would expect you at first glance to pick out the first time you've seen one of these. But if it has the same amount of distance and the same amount of time on the way up as it has on the way down, then it's going to lose as much speed as it gains on the way down, or lose as much velocity on the way up as it gains on the way down. Yes? No? Make any sense? Some body language? Okay. Now, we want to know how high it is. Probably later. What do you want to call its height? Well, let's see. Did they tell us where we had to define 0? No problem. I think they did. Where do you guys want to define 0? At the ground? At where it takes off? Or at the ground? Like right here? Okay. So we're going to call right here, this level, d equals 0 meters. What do you want to call up here where it turns around? How about h for height? Is that okay with you guys? And which way do you guys want to call positive? Up or down? Up. Okay. So we got up is positive. Now we need to say, okay, well, I want to know about the time it takes to go from here to here. I know a lot about its initial velocity. I know about its acceleration. I know about its final velocity. So I know a lot about velocity, and I want to know about time. And so I look at my equation sheet, and I say, which equation talks about being in one, moving from one place to another, and it has some things about velocity and acceleration and time in it. And it's, oh, we use the one, this one. Oh, but we want to know, let's look at what they asked us about, though. How high does it go? Right, you might use that for part B. We could actually get there using this one, couldn't we? Because we could say, oh, there's the amount of time. I could use this, and I know a lot about the velocity and the acceleration, so I can find out how long it took to get up there. Because I end up at 0, I start at 37, I accelerate, and then the only thing I'm left with is time. Once I add that time, then I could come up here and say, well, I know I want to know h, I know I end up here, I know about the time and the initial velocity now, I know about the time and the acceleration now. So you could do that, and it would just take you 2 steps. The one I was thinking of was actually this one right here, because it talks about, hey, your velocity is changing because you accelerated through a certain distance. But we can go either way. I'm going to go this way, just, yeah. So I'm going to grab this one. And I know that at the very top should be my V final. It's not moving, so my V final is 0 meters per second. That's squared. My V initial was upwards at 37, so that's positive. That's positive 37 meters per second squared. Plus, I have my acceleration, which is downwards, and since we said up is positive, that would make that negative. And the change in D, it goes from 0 to h. So my change in D is going to be h minus 0. meters. Oh, cool, I only have one variable, h, right? So I can rearrange that so that I have h by itself. And let's see what I get when I rearrange that as h by itself. So I get 69, I get the h equals 69.8 meters. You guys saw I posted the answers to these in our document folder, right? So you could check your work if you needed to, or you wanted to. So that's A. And now let's move on to part B. In part B, they ask us, how long is it in the air? In our Y, we said, well, we didn't say, but we could have put in there what you guys deduced is that it takes the same time up as down. Probably should have added that into it once you guys did it. So it takes the same amount of time to go up as it does to come down. So we could say, oh, okay, let's look at half of it, and then we'll just double that time. Or we could look at the whole thing, because we know it goes up at 37, gets to 0, and then ends up back down at downwards 37. So we could look at the whole flight, or we could just look at half of a flight. Which one do you guys want to look at? Half of it or the whole flight? Half? Look at half. First half or second half? First half? Okay. So we're going to look at the first half. We're going to look at how long it takes to go from 37 meters per second upwards to 0, given that my acceleration is downwards. That's why I'm slowing down. And then we'll double that time to get the time for the whole flight. If it didn't land at the same height, we couldn't do this, right? Because it would take longer on one leg than the other. You know. So we need to pick an equation that talks about the amount of time it takes to go from one velocity to another velocity. Which equation talks about that? This one? Yeah. The V final, V initial, that's saying, yeah, you want to get to this velocity, you got to start at this one, and then accelerate for this much time. So, let's see, we end up at the top, we're at 0 meters per second, right? We started at positive 37 meters per second. Plus, we accelerated at downwards negative 9.80 meters per second squared. And we don't know how long that took us. So we'll just call that t. So it took t to get up. And if I do that, hopefully I get a number close to 4, right? Every second it changes by 10, and if it starts at 37, hopefully it takes me close to 4 seconds to get down to 0. And I got 3 0.775510204 seconds. But I'm interested in the total time, which is going to be, as you guys told me, twice this amount. So the total time, the time to go up is 3.7755 seconds. The time to come back down is going to be 3.77. So 2t is the time that I'm looking for, and that would be 7.55 seconds. And that would be the time to go up and come back down. That is correct. All right, so number 4. You stand at the top of the cliff while your friend stands ground below you. Drop the ball from rest and see that it takes this time for the ball to hit the ground below. Your friend then picks the ball and throws it to you such that it comes to rest in your hand. What is the speed in which your friend threw the ball? Okay? Think about something that these two balls have in common. Excellent, excellent, and that's crucial right there. A of both balls is 9.80 meters per second squared down. What else? There's something else they have in common. What's the first ball's speed at the top when you drop it? 0. What's the second ball's speed at the top when it comes to rest in your hand? 0. So at the top, both of them have a speed of 0. Do you guys, yes? Okay. So at top, both have speed of 0. Now both have a speed of 0. There is one other fact here that I probably wouldn't expect in your Y because you don't see it yet. But so I will we'll go through it. I'm just going to do a little picture here, part of my why or my how. And so the first ball is here, and it goes down, and it has some velocity. Let's call that V1 down at the bottom, right? Because it's accelerating. Both of them are accelerating downwards at little g the whole time. Remember, g is 9.80 meters per second. And then the second ball starts here, some velocity, we'll call it V2, and it goes up. And when it gets up there, both of them in common have V equals 0 meters per second. Yes? Okay. Here's the big logical, oh, and they told us what, the time was 1.1 seconds? Okay. So the time for the red, they tell us, 1.1 seconds. They don't tell us the time for the green. So the time 2. We don't know. Call that time 1. Just to kind of organize our thoughts visually. Their movement looks very similar because they're both accelerating. They're both changing their velocity in the same direction. They both end up at the same point at 0. What do you think's true about their velocities down the bottom, or their speeds down the bottom would be better? It could be the same, right? Because if this one has 1.1 seconds to gain this much speed, this one has, or this distance, it has this distance, which takes 1.1 seconds to gain that much speed. This one has the same distance, and by our logic on the last problem, the same amount of time to lose that same amount of speed. Does that make sense? So we know that this one is going to take 1.1 seconds to get up to the top, since this one took 1.1 seconds to get down to the bottom. Yes? Because we know that to change our speed, okay, let's look at it, forgetting about the time for a second. What we know to change our speed, it takes both time and displacement. You got to, think about hitting the brakes in your car. You're going to move forward some before you come to a stop, right? So, forgetting all the time even exists, this one has 100 meters to gain speed. This one has 100 meters to lose speed. They're losing it and gaining it at the same rate. So if they go through the same distance and have the same start, they're going to end up at the same ending point. So that's how we know that V1 equals V2. The only difference is V1 is down and V2 is up. Then we're making one more logical step, is if it takes 1.1 seconds for the first ball to gain that speed, it's going to take 1.1 seconds for this one to lose it. Okay? And if we didn't see that, we could stick with, they're going to have the same distance. I think you'll find just the mathematics is a little bit more straightforward using time. So I'm talking about, we know the velocity, we know that it's changing its speed, it's changing its velocity, and it's accelerating, and we know how long it takes. So I'm looking at this left-hand equation again. It's changing its velocity, it's accelerating, and I know how long it takes. So I'm going to grab that one. How much time do we have left? So, it's V final. Well, I'm doing this for the green ball now. I might as well do it in green. I know that these two are equal now. The time, so I know that time 1 equals time 2. That was our discussion right there. V final is going to be 0 meters per second. It's going to start at V2. I don't know what that is. Is that V2 going to be positive or negative? Well, we forgot to define positive, negative. Which way do you guys want to define as positive? Well, okay, so we can say 0 is at the ground, but which way is going to be positive? Up. Get you guys adventurous and say positive is down one. Okay. So is the V2 going to be positive or negative? Positive, because it's pointing upwards, right? Yes? And plus, my acceleration is downwards, so that's negative 9.80 meters per second squared. And then, I know my time, right? My time is 1.1 seconds. And a little cranking on it. I get 10.8. I get that the velocity the guy threw the ball, the second person threw the ball up with is 10.8 meters per second. All right, we're looking at number 10 here. The cargo helicopter descending. What does descending mean? Going down. So we got this cargo helicopter going down at this steady speed. Now, if the helicopter's going down, what does that mean that the package that it's holding has to be doing? Going down also, right? That can be, sometimes you can forget that like in your car, the things in your car are traveling with you. You know, so they're going the same speed. So this package by itself is going down, and it's going down at a steady speed. So probably where I would start with this would be the package is moving downwards with the helo. With the helo. Yeah. Now, as soon as the helicopter releases the package, what immediately happens to it? It starts falling. Why does it start falling? Okay, and how do we describe that? How do we describe its motion that is being caused by gravity? Free fall. So it's accelerating. Which direction? Accelerating down at little g, which is 9.80 meters per second squared. So as soon as it's released, it's starting to accelerate downwards. And then we know, let's see, ground, how long it takes back to reach the ground. So it's going to take a certain amount of time to go from where it is down. And it's going to, is its speed, is its velocity going to increase or decrease as it moves down? It's going to increase and downwards, right? So you might even put that you understand that its speed will increase. Because it's already moving down, it's going to, and now it's accelerating. So we have our little package here, put a little bow on it, and it's going to move down like this. And we know that it's accelerating down at little g. It starts here with an initial velocity, can't remember what they told us it was, 1.7 meters per second downwards. And we want to know what velocity is it going at the bottom. So you guys okay with me calling that V sub B for bottom? We're told that up here it's at 51 meters, and here we're at 0 meters. Yes? So which one does it start at, 51 or 0? Starts at 51, so we'll call that D sub naught, and where it ends up, we'll just call that D. Sure. And if there's any of my terrible handwriting you can't read, just let me know. Good? Okay. So, we want to, and we don't know how long this takes, but that's what they want us, that's what they're asking us about first. So I know a lot about the velocity it starts at, I know it's accelerating, I know where it goes, it starts and where it gets to, and so I look at my equation sheet and say, which one of those is about where you get to because of where you started and how you were moving at the beginning and the fact that you were accelerating for a certain amount of time? The first one, the top one, the main one. That's the one I'm going to grab. And now let's plug in and see if we get to the right places. I end up at 0 meters. I started at 51 meters. They told us up was positive in the problem, right? Okay. Plus, my initial velocity is negative 1.7 meters per second. I don't know how long this is going to take. plus 1/2. My acceleration downwards, negative 9.80 meters per second squared. And again, I don't know how long it's going to take, so I just have to leave my t in there. Oh, cool, but I only have one variable, so that means one equation, one variable. Can you solve it? Yeah, definitely. How would I solve it? I might even use something like Wolfram to do it. You guys familiar with Wolfram at all? You can use it through any browser. It's actually, where do you think it's linked to? Our website. You go down here to the bottom, this little box says Wolfram Alpha. You type in your equation, 0 equals 51 plus negative 1.7 parentheses times t plus 0.5 times parentheses negative 9.8 parentheses star t caret 2. So all I'm doing there is just typing in my equation that I have right here. And then I hit the equal sign. And just a little bit of thinking. And it tells me my two roots. My two solutions are negative 3.4 and 3.057. Which one do you think is the correct one? Negative time or positive time? Positive time. So 3.06 should be my answer. Let's see. 3.06. Now, of course, you can use everything that you've learned in math to get the same answer. And that's probably a good idea. But there are other tools available to you also, just so you know they're available.